We're having a look here at the reciprocal function, which is anything in the form x times y equals k, where k is a constant. Now, to put this another way, anything where when we write a function, we normally write it with y as the subject. So if I've got something like y equals 2 over x, that's a reciprocal function. Now, reciprocal means where we flip something over, and so we call this a reciprocal function because we have something we don't know, or something that we can vary, something that we can change, a pronumeral on the bottom of a fraction, as opposed to y equals 2x, or even something like y equals x over 2. Well, x is still on top of our fraction here, so this is still a line. Okay, so that's still a linear function if we were to graph that, as opposed to 2 over x, which is going to behave very, very differently. Now, I've said that k can be a positive it can be a number which is positive or negative. We're going to say it's not going to be 0 though. Okay, we're not going to have x times y equals 0 or y equals 0 over x. A little bit boring because it does nothing. There's an infinite set of values that work there. But a couple of facts here: as x becomes very, very large, y becomes very, very small, and vice versa. As x becomes very, very small, y becomes very, very large. The same is true if that constant value k is a negative as well, except they're going to be switching, one as positive and one as negative. Or if I've got two negative numbers that multiply, that can give me a positive as well. We'll have a look at some examples in a minute of that. But if we think about it practically, let's say I'm wanting to multiply two numbers. Okay, I want to multiply some numbers to get 5. Well, let's even pick some easier numbers and say I want to pick some numbers to multiply to get 12. Well, I can pick 3 times 4 equals 12. I could pick 6 times 2, or reverse those. I could pick 12 times 1. And what I could start doing is I could keep making the first number way bigger, 24 times 0.5. Okay? Or I could make that 48 times 0.25. I could actually go and make it 120 and 0.1. Or I could go make it 1200 and 0.01. Hope you see the point I'm trying to make here. I can pick one of the numbers to be very, very large, but then the other number's got to be really, really small. Okay, and I could make some of those pairs negatives as well. I could pick -3 and -4. Would give me positive. And this is really what a reciprocal function is. As one of those numbers gets really, really big, the other gets really, really small, and vice versa. So if I were to do 0.1 multiplied by 120, it's the same thing, the same pair of numbers, but reversed. Okay, and if our curve has not been shifted up, down, left, or right, which is not something we normally do very much of, both the axes, the x-axis, our horizontal line in the middle, and our y-axis, our vertical line that runs through the middle, they are both asymptotes. So our curve will never touch either of those two lines unless it's been shifted in some way. So that means neither x nor y can ever equal 0 for a reciprocal function. And if you think about that as well, we're multiplying our two numbers. Let's say we're multiplying our numbers again to get 12. Well, I can pick a really, really big number for my first number, 12 million. Okay, now I'm going to have to divide that by 1,000,000 to get back to 12. That's going to have to be my second number. But if I picked one of my numbers as 0, there's no way I can get to 12 by multiplying. Doesn't matter how big, doesn't matter how small, doesn't matter if I pick a positive or a negative. 0 multiplied by anything gives me 0, not my constant value. So I can't have x or y in this case equaling 0, because the whole thing will fall apart in that case. And that's where our asymptotes come from when we graph these. The last thing to note before we have a look at an example is that the graph of a reciprocal function is called a hyperbola. Okay, now it's not like a hyperbole that you might use in English, an exaggeration. It's also not pronounced a hyperbola, a bowler who's moving very quickly and rapidly. It's a hyperbola, which means it's the graph of a reciprocal function. Let's have a look at what happens when we've got xy equals 4. Well, the way that we normally write that is y equals 4 over x by dividing both sides by x. And I've got a table of values here between 0.25 and 4. The exact same thing is going to be happening in the negative as well. I could select negative values there, but they will be mirrored. They will be exactly the same values except negative. So I'm just going to do one side of the table here. So I'm going to start with the easiest number, which is right in the middle, which is 1. If I substitute in 4 over 1, I get 4. 4 over 2 gives me 2. And I'm going to skip 3. I'm going to come back to it. 4 over 4 gives me 1. Now, if I go 4 over 3, that's about 1.3. Okay, that's 1.33333. It's 1.3 recurring. It's between 2 and 1 though, which is important. So what you'll see is my numbers are getting smaller. Okay, my numbers are getting much smaller here. And if we were to keep going, if we were to pick x equals if x equals 8, in fact, let's put that in there. If we put in x equals 8, that would mean my y value would be a half, 0.5. So what you see as x gets bigger, okay, y gets smaller. And if we go in the other direction here, if we go and substitute in 0.5, well, 4 over 0.5, or how many times will 0.5 fit into 4? That's 8. Okay, and how many times will 0.25 fit into 4? Or how many quarters are there in 4? Well, there's 16 of them. And so again, what you see as we move in this direction, as x gets very, very small, y becomes very, very large. And we could keep picking numbers for x that are so small that we get very close to 0, and y would just become really, really large. And exactly the same thing is going to happen here in the negative. So if I pick x equals -1, I get y equals -4. X equals -2, I get y equals -2, and so on. All these values are exactly the same, just in the negative zone. So if I start to think about graphing this, I end up with something that looks about like this. A couple of points we should label here. I've got this point here, 1, 4. Always good to substitute in where x equals 1 because it's nice and easy. I could pick another one as well. And I could say that's 2, 2. And it looks like my curve becomes a straight line at the top. It doesn't. It just gets really, really close to that y-axis. And the same deal when it becomes almost really flat on the right-hand side. It's just because it's getting really, really close to the x-axis. Now I can do the exact same thing over here in my quadrant where both x and y are negative. Remember, this is negative. This is negative. So in this quadrant down here in the bottom left, we end up with our negative values, and we'll have the exact same values here, right? Got -1, -4, -2, -2, and so on. And as x gets really, really big in the negative direction, y gets really small. And the same deal with the x values as they get really, really small as well. Y becomes really, really large and negative. So that's what things would look like if we were to graph 4 over x. Now I'm going to just change things up a little bit, and I'm going to go see what it would look like if I graphed y equals -4 over x. It's actually exactly the same set of numbers, except it's in this quadrant, and it's in this quadrant. And what we would have, these points are symmetrical. They're reflected. This would be 1 -4. And I'd have 2 -2. And then up here I would have -1 4 and -2 2. And the reason for this is if I've got -4 over x, it means that one of my numbers, x or y, is going to have to be positive and the other is going to have to be negative. Whereas when I had 4 over x, my red curve, that's where both my numbers would be positive or both would be negative, which is why I'm in top right and bottom left. But if I've got one positive and one negative, I can have x positive and y negative, that's bottom right, x negative and y positive, that's top left. Okay, so the curves look really, really similar. They're in fact reflections of each other in the separate axes there. I hope this has been helpful and you could now interpret and pick some of the key features and graph a reciprocal function.